And welcome back from spring break. Hope you had a good time. Do you go anywhere special, Hannah?
Nope.
How about you, Micah?
My sister bought a house, so I did some drywall.
All right. Get your hands all cracked up from getting plaster on them.
A little bit.
And I don't see many injuries on your hands, so you didn't mess with the hammer too much. Was it screw in or was it already up?
Yeah, we screwed it. I didn't do any plumbing or anything.
I kind of enjoy drywall. It's kind of a good physical exercise, and you see your accomplishment as you're done. Goes pretty quick. Were you doing ceilings?
Yeah,
Those are most painful.
some ceilings and a couple walls. There's some very small bathrooms.
Oh, good. But was this a project on your own for your sister, or someone helping you?
No, I don't know if you remember Nate Burr. He was actually there.
Yeah,
helping
yeah.
on the ceiling, and then my brother Jeff. And there's a lot of family members there. My brother Jeff was doing like plumbing and electric.
Oh, this is in Atlanta, right? She's living in Atlantic. Nate Verhey. I haven't seen him for a while. What's he doing?
He's a manager at Walmart up in Minnesota. So
Cool.
assistant manager.
Good guy. Well, I'm glad to hear he's having a good time and able to come and visit. Is he related at all, or just friends?
No, we just buddies from freshman.
Okay. Well, our plan today is to try to catch up a little bit since we hardly touched much on Chapter 6, which had to do with UML, and there is a homework for Chapter 6 that we could at least get started on, if not finished, and then be able to move on. Because if you look at the actual schedule here, we're supposed to be jumping into Chapter 7, but we might be holding off a little bit, trying to complete. See how object modeling kind of got squeezed in there just before midterm. We didn't get a lot on that, and some of it might have gone a little fuzzy after spring break here. So we'll review a little 6 and see if we can keep up here. See, the plan here is to be done with most of the chapters by the middle of April and have some time to put together our final project, which is a system documentation, an operation manual that's pretty much organizing all the things you've done into a nice operation manual, starting from here's how it was proposed, here's how it was designed, here's the schedule for implementation, and now here's how it works.
So it's for attempts.
Yeah. So let's take a quick look here at these ideas of object modeling, and then the plan is to then come back and actually work through or get started on the use case example. And I found something online, and the reason I like the online ones is I don't have Visio on my Ubuntu system on my office. Although I'm not disappointed with Visio, it's a pretty powerful program. I like being able to get to it from anywhere, and my Mac as well, which doesn't have Visio. So I found an online thing that I'm pretty excited about. We'll see if it works. But you're also welcome to use Visio if you have that, because that's a good program to be familiar with. But before we go into that, let's review some of the object-oriented concepts here that they drive us through pretty quickly here in Chapter 6. And the idea is not that we're writing any code yet, but we're thinking of things as objects, and languages that are object-oriented are easier to go from an object-oriented diagram to the actual code. And many languages, well, so far all the languages we've covered here, Visual Basic lets you build classes, although in the intro to Visual Basic we don't hit too hard on classes. Did you build a lot of classes in your Java work?
Main classes.
Okay.
I haven't really gone into classes that I create and
So
then
you-
call on later.
Right, so you've touched on at least some of the concepts. And with Java, you kind of have to do it that way. Everything's a class, and you put the little functions inside. And Hannah, you've done some Java? It's been a while now, right?
I don't think I've ever done Java.
Did you do C++ for your object-oriented? Did you take object-oriented? Oh, well, I thought it was a core.
I think it's a track.
Yeah.
Not a,
Oh,
I
okay.
haven't done anything with that since freshman
Yeah. Wow. Okay. So this is kind of more of an overview for you. We better check that. We don't want to be missing anything.
Well,
I'm pretty sure you've covered. So the object-oriented analysis and diagramming. Oh, let's see. You can't see that very well on the screen here. Let's zoom in a little bit here. Basically, is a way to just kind of think of the software and how software modules interact. And let's just look at just the concepts, and then we won't even worry about actual writing the code. Here's a little case discussion that we'll skip over that. Here's an overview of your concepts. And here's one, the first diagram they start with is, well, we've got this idea that objects like a car have attributes such as the color, the model, the engine size, the horsepower, and that's the attributes of the object. In code classes, attributes of, say, graphical objects on your screen would be the image that goes with that object, if it's a little game sprite, the color, the parts of it, if parts of it move, like the arm or leg, or if it's a rocket, the fuel, capacity, the speed, the direction, those would be all attributes. The methods of an object are the things it can do, and that would be where when you're writing code, that's the things it does. Like you have a object calculator calculates its volume or its area. If it's a ship in a game, it's moving or shooting or determining whether it's colliding with something. That's its methods. Rotating, turning, that's a method that an object changes, or it's like doing some calculations. The attributes would kind of go with the variables that are attached to that object. The messages part, that's a little fuzzier. That's where somehow the object gets some indication it needs to do something. And in the code, that's where in Visual Basic, you have events attached to objects that when it gets clicked, that is like a message that gets sent to it. And you decide in your code when it gets clicked, when it gets that clicked on message, do I explode? Do I call a function and change something, like if it's a start or stop method, starts and stops the whole system? Or if it's a ball that has gotten a message that I've just collided with the wall. Do you remember our little game there where in our methods we reversed its direction, changed some attributes like what direction I'm going based on whether I collided with the wall. And that was sort of like getting a message that, hey, something's happened. So objects have these three basic kind of classes of organizing how they work. And depending on the programmer, how the object works and how they've designed their object may behave differently, may have different attributes and messages as they've designed their software. But that's your basic object-oriented approach to treating things, trying to think of software as objects. Because it's such a popular thing, the UML diagramming standard is to draw a little rounded rectangle with an object, naming its attributes, and here's the name of a parent object, with various methods that this parent can do. Read bedtime story, drive in the carpool. We haven't seen how messages are described here, but we do see attributes, methods, and then the name of the object. We have then a child object, which has attributes similar to the parent object, except there's an additional attribute of a child that has a number of siblings attributes. And more methods pick up toys, eat dinner. And the parent probably has many more methods hidden here, like work to pay for the food that the children eat, clean up the toys that they have not picked up. The parent object has many more methods that aren't listed here. Because the child and parents are similar in behavior, they may actually inherit the class attributes. They may be part of a class of objects. So going beyond attributes and methods, and I'm skipping the dog object, which has similar attributes but different methods. You then have class types, and I'm going to jump across methods and messages to now classes. So we've gone from objects, which I would say are instances or instances of classes, now to going a little more abstract into what is a class. So remember, objects are particular instances of a use of a class. So now classes are basically the descriptions of objects, where maybe they have these things called subclasses, where a vehicle class, or going back to the example of the parent and the child or the dog, you might call those a class of living beings. Or now this is when we're talking about eventually using the car object, we would describe a car as a class of vehicle, special category subclass of car. And the reason the software people like to do this is it helps you to encapsulate your software into manageable pieces where I can describe a particular class that I might be using of a very general object, and when I have specific types of that more general class with special attributes that aren't used by other vehicles, I'll make a subclass called car. If I don't have anything special about car that's different than your average vehicle, I won't make a subclass car because it's not worth the extra complications of having a subclass if car is just a standard vehicle. Can you see why I might make a subclass car and a subclass minivan? What might be different about a car that I would treat that would have special attributes compared to like a minivan? Yeah, there might be more seating in a minivan, different use of a car than a minivan. If you think of minivan carrying more objects, maybe you're more concerned about payload and maybe capacity for carrying things and people. You use it in a slightly different way. But you know what? If I'm only using it to drive around and get places, I might as well treat them as just a vehicle. The only time I worry about a subclass if there's special attributes that I'm using a lot in my code that makes a difference how I treat a car versus a minivan. So this is kind of a weak example because cars and minivans are very close in behavior. Going back to the people example where I'd have a class of human being, parents and children do a lot more different things, and that might make more sense when you have a child subclass of human compared to a parent subclass of human. Because parents and children, attributes of parents, there's a lot more things to worry about. Education, job. Children, I would say, have a lot different attributes than a parent. Going back to our case study where we have a variety of people, what might be the classes of people interacting with our system, with the TIM system? Yeah, so we'd have instructors. What else?
Would instructors be a subclass of like users, or
Yeah.
would they be their own class and then they'd be?
They'd probably be a subclass of users.
They would be.
Yeah. But remember, this is all very flexible. If you're a software person, you say you don't like subclasses because they just add complication. You could just have users with all the possible attributes of all users where, say they have a degree. Well, for a student, the degree would just be blank because they haven't had a degree yet. So it's your choice as a programmer whether you want to create subclasses, and you can choose, well, I'm just going to have one huge class called users, and all the attributes of every possible user, including teachers and administrations, I'm just going to treat them all as users, and based on their many attributes, I can define what they do. Another programmer might come along and say, no, I want a very simple user class with their login name and their password, and then if it has anything specific to a student, I'll form a subclass of user, and only things that are specific to students would be in that subclass. So it's very flexible in how you design it, but one programmer might say, I'm going to have subclass student, instructors, administrators, where if I go and dig through the code of our Moodle system, I find out that from what I can tell, everyone is a user, and they have roles assigned to them in their attributes. And out of the database, whenever I go to log into a course, it checks to see, am I a teacher or a student in that course based on a role attribute. And there may be even a method that says, see what my role is. And then as I go into a course, I could be a teacher in one course and a student in another course where I'm the same user. So as you develop systems, you may find that it's more convenient to treat everyone as a user, general class, and forget about subclasses. Other cases, say you're programming a game, you have vehicles, different types of vehicles, and some may be so radically different that rather than pile tons of attributes that for one type of object you don't even ever use, another type of object you're using all the time, your code gets a lot harder to read if all your attributes are packed into one single class of, say, a vehicle. So as you develop really specific rockets or shuttles or all types of, as you develop a game, you may find developing different subclasses helps you to not have to go back and change other code because you've got all your rockets or bullets or simple transport vehicles all working. If you change some code having to do with the rocket or super fast transport, you don't have to worry about the code that's already dealing with the regular vehicle. So that's another reason to have subclasses, because remember, as you develop code, if you develop code specific to trucks and only worry about the attributes of a truck, you don't have to go back and fix things because they've said, you know what, we've decided to add another attribute to make our code work better. If you come back and change this class, all your code for any subclasses that use it have to be changed. But if you only change the code that deals with truck subclass, you haven't messed up rewriting or recompiling this code. And remember, with a big project, you're going to have a separate person working with the attributes and methods of the different subclasses. So the encapsulation idea, that's a major concept of object-oriented. Encapsulation means the team or the person working with the code dealing with trucks doesn't have to worry about what's happening with the changes dealing with minivans. If someone in the upper level says, you know what, our vehicles all need another method to having to do with tracking their efficiency of fuel, when they make a change to the parent class, all your programmers have to rewrite code or at least recompile to make sure something hasn't broken. So that's the big idea with object-oriented, breaking your code into little pieces. Encapsulation is the concept. You're keeping the problems and the bugs associated with that code located in one place. So as a project manager, encapsulation helps your life. When you've decided what a vehicle is, cars can go ahead and play with their code, and unless they request changes to the major class, they don't have to deal with these people changing how minivans work if they're specific to the minivan attributes. Another case having to do with the general employee class, and then managers have different attributes. This would be maybe in something like the TIM system, where we're dealing with the HR. We could say, you know, we have employees of the TIMs, that's a special class of user. Now we're saying, well, there's special subclasses of those same kinds of users.
Do you ever get into like a subclass of the subclass?
Oh yeah, you can go on and have different types of managers as their subclasses. So you can have multiple levels of what they call inheritance. And at this point, we're just talking about the concepts. Different programming languages will make this easier to implement than others. And just because it's an object-oriented language that says, oh, you're writing C# or Java, doesn't mean your code's going to automatically become object-oriented. It's up to you as a programmer to use the language as it's intended. And you will run into programmers that will write Java code that has nothing to do with objects, and it's completely impossible to read because they've just assumed because they're using Java, it's object-oriented. They have a class and they do crazy things with it. Doesn't guarantee they will be following these rules. It's easy to break the rules with certain languages. That's one thing C is notorious for. Very powerful language. You can do object-oriented programming in C, but you can also very easily break the rules and not follow object-oriented practices, not encapsulate your code, and it'll work as a program, but someone that's pure object-oriented will say, wait a minute, that's not really object-oriented. You're just writing C code that's just spaghetti code. Other programming languages like C# or Java make it harder to break the rules, but also then for some programmers that's a limiting thing. They want to have the creative ability to break the rules when they need to and optimize code. And programmers that have learned the non-object oriented programming style first sometimes are go a little wacky and break those rules because they're used to not needing them. When I learned programming, I was happy to have learned Pascal first before I was thrown some Fortran code, which completely non-object oriented. Having a little Pascal experience that forced me to name my variables first and then name my functions first and then use them forced some structure on my programming when I was first learning. So as you do programming, even though the object-oriented compiler or the environment you're in may feel like it's stifling you, it's helping you to be organized. Okay, so we've talked about the objects. Here is again the idea about inheritance, the relationships between classes, where parents, a child inherits attributes of the type of employee here, but has additional attributes as a subclass. Here we have similar methods. It inherits the same methods, but it can actually add additional methods. So this is the parent class is employee. The child class is the instructor, a specific type of employee. And in this particular example here on page 256, the employee or the instructor is an employee, so it has all these same attributes. See how they highlighted that there? Same attributes, but the one extra attributes that an instructor has in this example is the type of instructor. The methods, in this particular case, the instructor class has no additional methods, at least shown here in the diagram. Now in this case, someone might look and say, you know what? Why do we need to make a separate subclass? Why don't we just add to the standard employee class the title? And that would be a standard attribute of every employee, rather than going through the trouble of making an instructor subclass just to add this one little extra attribute. Most of the time when you make a child class, it's because you have a special kind of employee with a lot of extra attributes that no other type of employee needs, and it then gives you reason to make the subclass, because you're adding some complexity by adding a subclass. So you, as a programmer, you always think, okay, is it worth making a subclass? Is this different enough, and I'm going to have other kinds of employees that don't need to worry about the extra attributes of this subclass? Does that make sense? And this is all abstract. Notice we haven't written any code yet, and that's the trouble with the system analysis is, as you've learned some programming, you've probably already gone and done some prototyping in the language you know as you're trying to build up the ideas and prepare for a project. You have to kind of hold back and say, okay, those are prototypes. Let's go back to the table and make sure our general diagram and approach to a system is following our general abstract, here's how we want to design it. Don't get stuck that, okay, I have to write it in my code, my language, and because I'm writing in Java, I can't do a particular method. Nope, you have to stop and say, wait a minute, let's go with our design class. Later on, we'll come back and look at the code. You may have some insights into how to design some things, knowing that databases won't work right if we have a particular, all these subclasses or methods. You can always come back and say, wait a minute, let's try to organize it this way, because in the back of your mind, you know how it's going to work better with databases if we design it a certain way. So going through a project several times from design to coding, you'll come back and understand better some relationships, as you know that certain ways that we've designed these things, we know it works better through experience.
When you use this code, is this, I mean, are all these subclasses in their own blocks of code, or are they kind of a global variable that you call on later?
Yeah, when you code, you will have, there'll be a separate file for each class. Then depending on how big your project is, they actually may be in separate modules, and they could even be in different languages. That one team might work in one class of object actually working in one language. Very common with with embedded systems, where down in the low-level code, like a driver, you have a printer driver, and that's written in lower-level language, sometimes even assembly language, and you can treat that as a class. And in your operating system, it's actually probably written in completely different code. But then you have other things interacting with the system, could be written in a whole different language. But yet, and so they would be treated like a separate module. But they all interact, and in the diagram, they would be different objects in your system diagram. If it's one project in one language, like one Java project program, like a mobile application, they would be, at least if I'm using something like Eclipse or NetBeans, there'll be separate files in the project that a subclass simply includes the parent class. It does an import. Have you done imports with Java? At the top, it'll import a particular definition. That's basically what that's doing, is saying, I'm using this, I need to know what the definition of the different objects. Same thing if you have a parent class, you would import the definition of the parent class, and then in your code you'd be my class inherits or uses or is a subclass of a parent class.
The main thing I've done is I import scanners for
Right.
user input.
Yep.
So I'm calling on, is that a class or is that like a method of a Java class? Because I didn't write
Well,
that.
when you import the class, you're importing the definition of the class with its methods and attributes. And the code is somewhere else in a library. But what your compiler needs to know is what attributes are there, integers, strings, and everything. And then when it compiles it, it knows I'm looking for this in the library. Here's the parameters it takes, and I can fill in my attributes and then call the library function. And it's structured exactly the way that library function is expected to receive parameters, or he has a pointer to an object, and he knows exactly how that object is formed in memory, and it can get all the different attributes and call the methods without crashing. It's very complex down in the compiler. The compiler is doing so much for us. As long as we follow the rules in compiling and getting definitions of classes, then the code works nicely for us. Now here's the part we're going to be seeing what we can get to today, is actually modeling the use case for a particular project, where we're getting closer to thinking of dealing with the code and what happens. We step back and say, okay, well, how does the actor interact with the particular system? And this is one way of modeling the interaction with a system called use case, where you have a little stick figure that does something to interact with your system, and you basically document what happens as that goes on. Here's another use case. The passenger makes the reservation. Here a patient is making an appointment. And then you have a customer placing an order, bus dispatcher setting an address. And the rules are, with each arrow, you have them performing a particular action. And you can go into details now into that use case, talking about as a student adds a fitness class, it uses information, or let's see how this goes. Is this using this? If we look at this, the product, yeah, it produces, in order to know whether I'm in the, let's see, I'm adding a class. Which one uses, I'm trying to figure out which direction this uses is going here. They describe this. Okay, the manager checks the fitness class schedule to see if they can be in the class, and then finally notifies the students whether they can register. So that's the add new student use case. Looking at the activities in a system for how a particular thing happens forces people to say, okay, what needs to happen when I need to add a new student to the system? It's getting closer to, have you done pseudocode? Remember doing pseudocode? Where it's, hey, I'm not writing code, but I'm trying to be careful in the things that happen. That's kind of what a use case is forcing you to do, is think about when I do a particular thing in the system, here's the things that have to happen. If it doesn't work right, like if there's a problem and I can't do the successful completion steps, here's what I need to do in my alternative. So you could almost think of the use case description. If it's a decent description, you could almost see that that could look like not taking very long to actually go to code in particular language I'm writing that would do exactly what the use case is describing. So a properly written use case documentation will make it clear to someone what need to program that particular use case, hey, what their code needs to do. And if it's too abstract, they may come back and say, well, let's describe what happens in step 2. What needs to go on when I see step 2? And you might add more details into what needs to happen. So this is the use case modeling, but that's not the only modeling. As we go, after we've done a more detail on a use case diagram, let me zoom out a little bit on this one. Here is the use case details. This is the use case diagram of a particular use case of handling a work order where we have multiple entities interacting with our system, and we have different things happening that we give labels to: create work order, update work schedule, prepare invoice, and a general sequence of events, generally top to bottom, as each entity does something to interact with our system, and then the different pieces interact with other pieces in our system. So following through this one, we see a use case diagram. We have different activities: creating the work order, update the work schedule, prepare the invoice, and then we have kind of very general verbs on the arrows. Update, that could mean a lot of things, but it's just, and then the user here writes or checks the invoice. So fairly general, flexible wording here. Probably not as strict rules as on our data flow diagrams. Basically just generally describing what happens in our system as we perform a series of tasks. The class diagram, that gets into more detail on how things are related to one another. We'll be getting into more of this as we look at the database, but we'll see in class diagrams we have to deal with cardinality between classes, and it gets pretty complicated. But I'll let you kind of review that. Here's something looking similar to use case and almost beginning to look like data flow diagrams, but it's more basically showing relationships and then activities between objects. And we'll be looking more at that as we get into further chapters. Sequence diagrams, we mentioned at the start. I'm not going to make you do one, but it's kind of describing in more detail the sequence of things that happens as certain activities go along in our system. But in order to get through this chapter and kind of overview these ideas, I'm not going to make you do a homework on this sequence diagram, but at least understand how a sequence diagram can help someone describe the sequence of events happening in my code in a graphical way, eventually leading to well written code that follows the general design ideas that have been discussed in a sequence diagram. And remember, the difficulty with a typical system is at the design time you've talked about sequence diagrams, you get to the code and you realize you might need to change something from how you designed it. It's going to be a lot of trouble to go back and update sequence diagrams because they've been thrown around and rewritten several times. So often your sequence diagrams may not match the exact code, but they're close because you use the diagrams to build your code. Unless you're super meticulous, I wouldn't guarantee you that your sequence diagrams that you wrote 2 months ago are exactly matching the code. That's why you got to be able to read other people's code to see, is it matching how we said it would work? If not, you'll be able to recognize, okay, we added an additional step here because we realized there was a bug somewhere and there's something else that happens. But in general, we followed this flow and didn't throw out the sequence diagram completely. And that is why, because of that, some programmers are very bad at even doing this kind of documentation because it slows them down in their coding. And the only way you know what another programmer is doing is if you can read their code. That's why back in the programming class I obsess about commenting your code, because if you have that as a habit from the start, people can read your code and see, because maybe you documented well, they can almost see the sequence of things happening in your comments. And if you make some change, you can update that in your comments. So we've got other ways, activity diagrams, another method. But let's jump now to see if we can do a use case diagram as Jesse has asked us to. And I think Jesse in our homework has actually asked for 3 use case diagrams. Let's take a look. Down here in object modeling, let's look at the case study. And I think this came from looking at the case study. That there were 3 use case diagrams that they were asking for. Let's check. Let's go back and check the chapter 6 online case. Here we go. Go to the inbox of session 6. And Jesse has asked for a lot of things, but we're not going to be able to do everything. Let's see what Jesse has asked for. In the first email here, logical model of Tim's, Jesse has asked for, I think this is the use case, show the interaction of a student with the system. That shows that interaction. Identify at least 3 of these. Think of how the entities relate to each other and to the overall system. So we have to discuss that and think of, back in that example, can we think of a description for each use case, just like they showed that description in the chapter. And then draw a use case diagram. So Jesse has asked for 3 use case diagrams. What I'm not making you do is a class diagram and relationships between class with cardinality. That would be a whole nother project. And I think they had asked for a sequence diagram as well. That's your sequence diagram. And one thing else that Jesse was asking for, state transition diagram. Jesse says they're not hard to do. Actually, your first state transition diagram, it does take a while, so I'm not making you do one. I'm just wanting you to be able, in this particular class, I want you to be able to recognize the different types of diagrams, but only actually having to do the actual first one. Because to me, looking through the systems, I see the use case seems to be the one that's, to me, most, say, more general of understanding how you're working with the system. From the manager point of view, I'd say this kind of use case diagram, I'd say is easiest to understand. The rest is getting into more detail. So let's start with the broader view. What we're trying to do is create a diagram like this with, did I have the, with this part added. So we're going to have a drawing of how a student interacts with the system and how an instructor may also interact, but then have a box like this describing, okay, here's what's going on in that particular use case. Is that making sense? So we're going to do something like this. And let's see, do they have a, didn't they have one that had, was almost,
We're gonna do 3 of them, or?
yeah, we're going to try to do 3 of them. So let's think of now, what can we describe in interaction with the system, and then go basically make the diagram. So going back to the email, think more about how the entities relate to each other and to the overall system. And they've given us one example. So we could start with this one. When a student interacts with the system, oh, I guess they didn't say. How does a student interact with the system? They didn't say specifically. Here's, for an example, a student. What does a student do with the TIM system? Let's brainstorm a little bit here. And we'll bring up our notepad. Let's think of our use cases. Now, in the example in that homework, let's take a look at the assignment. Here is something we did in the past. We were planning on creating well, we actually designed it. That you know those TV monitors. There's a program called Rise Vision that if you have a little computer hooked up to your monitor, that little computer can call this Rise Vision software up, and it makes a nice display. And it can connect to our Google document of calendar of activities. It could bring up documents showing announcements. And we actually designed how it might work. And one of the use cases we described was, well, the person at the front desk would update announcements in Google Docs. The Rise Vision software automatically would see the new announcements and display them on the announcements screens of the TVs. So that would be one use case, where the person at the front desk would update their announcements. We also did a use case of the athletic page. They update us an athletic schedule. How did their interaction, how does Rise Vision show the updated athletic schedule? And another cool thing Rise Vision could do, it was actually show links to streamed video where you could see video clips from the ongoing athletic games. So we described some interaction with users and this announcements NG. That was our case study for that year. So let's brainstorm just different ways that entities interact. So let's first list our entities, our little stick figures that deal with our system. We have students, and I'll just call it a student entity. We have an instructor. We have administrator, like the registrar. We'll call it the registrar. And we also have that other external entity, the accounting. We'll just call it accounts. What are some activities? What does a student do with our TIM system, or instructors do?
Register.
Yeah, register for courses. So we'll say student registers for courses. And we can think about that as one use case. And what does the instructor see? How does a registrar verify? Are they able to register for a course? Let's just say they register for, let's just do simple. Let's just register for one course. What happens when a student registers for one course? So that would be one use case.
What about instructor grades?
Okay, instructor.
Or like grading assignments, I guess?
Yeah, instructor grades assignment. So we'll think one assignment. What happens with our system? What interaction occurs, including the student sees the grade? What's one more interaction?
Student pays accounts.
There you go. Student pays bill. There's plenty more we could come up with, but there's 3 basic ones. So let's look at then the use case for student registers for course. And since we like graphics, let's go ahead and start your graphic program. I discovered a cool graphics program this morning called drive.draw.io. And what I love about this is it connects directly to my Google Drive, and it's a lot like Visio and how it works. I was impressed with it. Doesn't require Visio to be installed, so I could run it on my Ubuntu system right on my desktop. And I'm going to create a new diagram. And if you go over here under templates, you can start with a template or you can start with a blank one. But see, it has templates for software design, and in there they have example. I think I came across an example. Oh, I thought I saw a use case. Oh, here's one of their example use cases. Now, you don't have to use that template. You can start with a blank one. But here's a use case you could start with and then modify. But I'm just going to start with a blank one because it's easy enough. There's arrows and stick figures, which I have over here in my general. So I'm just going to go with blank diagram. So I'll go basic, blank diagram. I can give it a title now or rename it later. Might as well give it a title now. I'm going to call it CS412 SP15 because I have so many diagrams. If I don't keep that in there, I'll lose track. And I'm going to paste in the name, student registers for course. Might as well call it 05 since this chapter, or sorry, this is chapter 6. Now we could put all the use case diagrams on all of them. Now if you're using Google Drive, if you haven't logged in or started it up, it first wants you to authorize, and I'm going to authorize it through my Google Gmail account that I'm logged into. And it'll show up right in my Google Drive. So it's cloud capable already. I don't have to worry about the OneDrive. I'm sure Visio will let me use my OneDrive. So I bring in my entities, drag them over, put them in the different spots. And let's see, if I click on one and just start typing, it puts the title right underneath it. Student. Click on that guy, instructor. And let's put in our registrar. It has to interact somewhere with our system. Registrar. And let's see here. I probably want to show the title right here on my drawing if I ever print it out. Although it's in my title, let's go ahead and do a text. And let's see what happens if I just paste that text. Does it stretch? Yes, it stretches my text out for me. Oh, it looks like a paste actually creates a new text box. I don't even have to start with one. I think if I double click, I can get into edit mode of the text. And to delete, I just select it and hit the delete key. Yeah. And here's my title. Let's see if I can make that nice and big. I'll increase my font size, font color. There's my font size. There. So my student registers for course. I can rotate my text. It's a lot of flexibility there. I can enlarge my figures if I like them nice and large. And can I make the lines bold? I think I can. There, I can make my lines bold. Let's, make a dotted line. I can make a dotted line stick figure. Oh, there's where I can make my thickness. Here, I can increase the thickness. If I like the thicker stick figures like I see in the book, you're going to make them different colors, different styles. Pretty easy little interaction here. But now let's get our diagram going here. We're going to want to make room for our description below. So we don't want to get too complex. Like they did in the book, we have a little box around our system here. Or was that? There. And do a little box and then the circles inside of it as our people interact. So let's go back to here and do that general outline. And then we'll fill that with a light color. So this will be our system, and inside of there there'll be different activities. And let's give it a shade. Ooh, cool shading. And no border. And now comes our circles. I'll make them into ellipses. And if you want to give them different colors.
What is that? Square, rectangle?
That's just my border of my system. Like on page, what page was that? 260. So that's kind of our model example, what we're going to do. And now I figure out what does my student first do. We could assume that they've already seen a list, or we could say there's something that provides a list of courses. And let's see, back in our example here, the circles represent activities in our system. So we could say one of our first activity is produce a course list. So display course list. And I can decrease that font size. It looks like it remembers the last font size that I used, so don't want that one to be so big. Oh, looks like I have to change the font size there. Oh. Try that again. Not behaving. There we go. So I display a course list, so the student views course. So we'll draw an arrow, and you can choose, I think I'm going to go with the fat arrow. And the book here, what did they use? They used fatter arrows. I can always make a single line arrow, make it a little fatter. I'll do that, because these bold arrows I tried, they're kind of big. So let's do a single line, and the start of the arrow is on the little X next to that circle there, and if you get it right on the X, the thing will turn green to know that you're touching it there. Then when you move things around, they'll stay stuck to it. And the student views the course, and I'm not sure if it matters. I'll just put it pointing to the hand. Student views the course, and I'm going to adjust the thickness of that line. And I think I'd rather have it be, what do we have over here? We have those a darker blue. I'll try to copy the book style, so I'm going to make that a blue color rather than the dark black. I say it's pretty user-friendly interface. So the arrow list, again, very general, similar to data flow. We're just saying, okay, it's showing display. So we'll put display on that arrow. Let's see what happens if I click on that arrow and just type display. So it displays the course list to the student. And then what does the student do? Let's copy paste that one. And it's going to be probably something about checking for availability. So we're going to probably do a course request. Let's put that there. Course request. And that's going to have to check an availability of the roster of the course. So let's do an arrow. I'm going to copy paste that arrow so I don't have to keep changing attributes of arrows. And then I'll just change its name. Let's see if it's attached. Oh, that one didn't get attached to my student's hand. Let's see if it'll let me attach it. There. So made a course request. This is now not going to be display. It's going to be requests. And it looks to me like the registrar is going to be the one that's going to be confirming whether it's available by doing a separate activity called check for availability. We'll just say that the registrar confirms the request. Draw a little arrow from the registrar to the course request activity. And then Or do I do a separate course approve request activity? I'm wondering about that. I'll put here this one should say approve. Or confirm. And then
The last one could be like enrolled, right?
yeah.
Or something. Takes the people enrolled.
So once the request has been approved, then we would update roster, right? And since that text fits a little better, I'm going to adjust my text there. That's 12 point. It's not behaving consistently how I changed my font. Okay, so request, approve, and now, since it's been approved, we would then add students. So I will do this activity tells that activity add. So we'll draw another arrow, copy paste. And change that from request to add or enroll. Now the roster's been updated and the instructor then gets informed or can see the new roster. So maybe I'll have a display roster box. So I'll copy paste that one. Have a display roster. Whenever the instructor needs to see the roster. So the update roster does it inform the display roster? Let's see what our example. I guess we could just do the update arrow. That's a very easy arrow. We'll just do an update. We'll do the update arrow. The roster display gets a message. Hey, you've been updated. And let's put that there. Oh, make sure it's touching. Where's that little guy? Now the student should get some kind of approval notice, right? So what do we do about the student? Let's look at our example here. Request service. In this one, we're not seeing that the customer gets information back from requesting service. We just see the invoice. I would bet the invoice, the customer can see the invoice at some point. And maybe to avoid crossing lines, you might put the customer down here so you see the new invoice. Or actually, would the customer see the invoice? The customer would see the completed work. It's not included in this particular example. All we see is the customer doing the request. In our example, does the student see something after requesting a course? I suppose they would see themselves listed in the roster.
Can you draw an arrow from display roster to both student and instructor?
Yeah, I think I might do that. So I will see, and I can decide whether I want to draw the student twice or just draw multiple arrows to the one student. Maybe different. Don't you do it to his foot? So that would be the course schedule display. So the student can see the display of the roster, and I can adjust my arrow connections to the different objects. I wonder if I'm just on the edge, does it optimize where it's connected? Let's see what happens. And then display roster, we'll also do the display arrow to the constructor. And then, because I have the connection, if I move the things around to adjust, I have that. Now, the only thing left to do now is to write out that example of, okay, now here's what happens. Where's my little description of it? Here. Can we now write out something like this? So it's the register for course use case. Can we describe successful completion? Well, the class is not full, it gets approved. Alternative, the registrar shows it's not approved, the student gets a sorry, can't register status. So using this now, let's see, what could I can download this, download as a JPEG, PDF, or XML. Let's see what else I can do. It looks like it doesn't download it as a Visio diagram. Portable document format, PDF. It'd be nice if it would have been able to download as a, maybe the XML is viewable.
Scalable vector, you'll probably be able to copy and paste it.
PNG with embedded XML, that'd be interesting. I don't, would Visio take scalable vector graphics, I wonder? It'd be interesting to see which of these could actually go right into Visio. I'm guessing this might be perhaps compatible. It's draw.io. So that's the one drawback. Since it was so much like Visio, I was hoping that it could export to Visio compatible. But at least I could do PDF. And another cool thing, I can just share it as a link. I can, just like any Google Doc, I can create it shareable. So since PDF's the most compatible, if you use draw.io, just save it as a PDF. If you would prefer Visio, after getting some experience with draw.io, you're welcome to do it in Visio. And the idea here is just get familiar with this use case, and by having done 3 of them, you'll be most familiar with use case. Those other styles are UML techniques different software teams will decide to use. So that's it for today. A quick overview of UML modeling. If you have any questions, feel free to give me send out an email or anything, and I'm not going to be too fussy as long as it somewhat makes sense of what happens here, because that's what will happen on your team. As you describe this, some people may ask for more detail on what does that request mean on that arrow.
So this is due Thursday, is that right?
Yeah, we can have that done by next class period.